Okay, here we go. Let's have a look at these. So here's what I'd like to do. Let's look at this one first. Okay, scoot forward. Come on, scoot forward. If you're way in the back, that's not a bad. You're not gonna be able to see as well. Scoot forward.
Well, let's do it.
I have ADD.
Okay, so here's what I want to do. I want to go through how to do two things. How to start with an equation and come up with a graph, and I want to do the opposite. And it's, people have most of this stuff down, but the part they have trouble with is the dilation factor. Oh, that's really clear to me. That's where the issue comes up. So let's look at this guy. Let's see, is that the one I want? Yes, it is. Right there. Okay, so let's see what happens here.
Oh yeah. To do these assignments, you have to use Desmos, right?
No, you don't need. I'm going to use Desmos to show you something, but you don't have to use it. Okay, now everybody should be quietly listening to me and answering questions when I call on you. Okay, so if we want to do this, what's the value of A here in this equation? Okay, good. We have to be able to pick out the values of the parameters, right? This is in vertex form. It's in the form A times x minus h squared plus k, right?
Yeah.
Okay, so the value of A is
1/4.
1/4. Good. And that's going to be step one is going to be dealing with that. What's the value of h and k?
-1.
5.
Oh.
Positive 1 and 5 because it's being subtracted, right? So 1 and 5.
Yeah.
That's going to be step two. So when we want to create this graph, let's do it in 2 steps. And I've got tons of good graph paper. You can use that on the test if you want to. I would encourage you to. So the first part is going to be, let's take a parent graph and let's dilate it by 1/4, by a factor of 1/4. So we're always going to start everything with our parent graph, which is the graph y equals x squared, right? So that means it starts on the origin, the vertex is on the origin, and if I go over 2, if the x value is 2, that's the input. 2 squared is 4. 3 squared would be 9. 4 squared would be 16. That's how I get those points, right? Okay, so here's our parent graph. Now, I picked some convenient points, but we would also have points at 1, 1, at 3, 9, at 5, 25, etc. So if A is equal to 1/4, think what A does. A is what we multiply the y values by, right? Okay, so if I'm going to multiply the y values, I'm going to multiply the y values by A, and you already told me that A is equal to 1/4. Both of those would be convenient points to multiply, wouldn't they?
Yeah.
Right? So what would happen if I multiplied this y value by 1/4? What would I get?
Go down to 4, right?
Be 4, right? So I'm always going to multiply the parent y values. So 16 times 1/4 should equal 4, right? And so this point right here is going to get moved down to a point that's got a height of 4, right there. Okay? What about this one? If I multiply the y value of 4 times 1/4, what do I get?
1.
1. So that point's going to move down to there, right? Everybody see that? Okay, so let's watch that. So if I'm going to create a new graph from the red graph, and let's make it green. Okay, so there's my green graph. And I'm starting with those. Actually, let's get rid of this one. Okay, I'm starting with those points. And I'm gonna change A, because notice that what f of x is, I'm just multiplying A. Everybody see that A right there? I'm just multiplying A times x squared. So let's tweak the value of A. What if I make it 1/2? Well, what just happened? If A is 1/2, look what I did. I just multiplied all the y values by 1/2, and 16 turned into A, right? Notice those points are lined up vertically. They have the same x values, but the y values both got cut in half. So if I multiply by 1/4 as a decimal, that's just 0.25, right? That's going to be the shape of our curve, isn't it? That's the dilated graph. Everybody see that?
Yeah.
So that's step one, right? Step one was we just multiplied the y values by 1/4. And in the solutions to all these problems that I've built, this is the graph that I've literally taken from the solution. So we started with the parent graph at 2, 4, and we multiplied by 1/4, which squeezed that point down to there, right? Step one. Okay, now what you told me the values of h and k were 1 and 5. So from here, it's really simple. Right now, all we've got to do to get our answer is we're going to take the green graph. Let's get rid of the red one now. Okay, we started with the parent graph and we dilated it. We squeezed it down. So I'll just get rid of all that stuff. The next step is we've got to translate this thing, right? And so all we're going to do now, we're going to build a blue graph from this one. Okay, so we're going to build a blue graph, and what did I just do? Hang on here. We're good. X minus h. Okay. Yeah, we're good. Okay, so there's our blue graph, right? Now let's translate this thing. What was the value of h that we were going to use?
1, right?
1. Okay. So let's turn h into 1. So I'm going to subtract 1 from x. What'd that do? Just scooted it over to the right by 1. What was k?
Was 5.
So now we scooted it up by 5. Right? Everybody agree?
Okay, so it's
So-
going over 1 and then up 5.
Yep. What happened to our green one here? Oh yeah, okay, I should have the point. Yep. Okay, we good? So everybody agree the green graph just got translated up to the blue graph? Right? Everybody see that? And the blue graph is our answer then, isn't it? Right? We took the red graph. You guys in the back, please don't talk. It's bothering me, so it's bothering other people. Stop. So the red graph got squished down to the green graph, and then the green graph got translated. So we just followed those 2 steps, right? Everybody agree?
Okay.
Dilate it, translate it. No big deal. Okay, let's try one more. How about one like that? Okay, what are the values of A, H, and K?
-5, 1,
Okay, so A is
Negative 1/5.
-1.
-1/5. So step 1 is we're going to dilate, right? H and K are -5,
And positive 1.
+1, right? Okay, because remember, we're just matching this to f of x equals a times x minus h squared plus k, right? We're just determining what are the values of those parameters that we're using for a, h, and k. Okay, we got it, right? So that's going to be step 2. Okay? So let's look at, that's going to be, no, not that one. Where is it? Right there. Yeah. Okay. So there's our parent graph, right? There's our convenient points. Okay, we got a whole bunch of them. So now, if I multiply the y values by 1/5, which one of those points is going to be the most convenient? If a is equal to -1/5,
So 5, right?
yeah, it can be that guy, isn't it? Right? Because we're multiplying the y values. Look at these y values. 1, 4, 9, 16, 25. Only one of those is divisible by 5, right? That one. Agreed? So that's the one we want to keep. So that's the only one we're going to focus on, right? And we know that we're going to multiply whatever the input y value is, right? The parent y value gets multiplied by a to give us the output y value. So we're inputting a 25 and we're multiplying by a, which is which is negative 1/5. So what's the answer going to be? Negative 5. Yeah, good. So we're going to end up with a negative 5 is going to be our output y value. So where's that point going to end up? It's going to go straight down. It's going to end up down here at negative 5, right? Okay, let's see that happen. You guys close those up. So let's do that. So let's create our, here's our green graph, right? There's the one point that we're going to tweak. Now let's change A. So what if we make A, you know, if it's 0.8, then everything's going to get multiplied by 0.8. So it goes down a little bit. 25 goes to 20, right? If I multiply by 0.6, that's 3/5. 3/5 times 25 is 15. What if I multiply by 1/5? Does that make sense? Right? That's not the A that we want, but if I multiply the y value of the parent graph, 25, by 1/5, I get 5. Okay?
Yeah.
But we're going to get negative 5. If we multiply by negative 1/5, then I have to write it as a decimal, but everybody agrees that's negative 0.2. Okay. Look what we end up with. There it is, right? So there's our dilated version of the parent graph. There's step 1, right? Okay, yes, go check out. Okay, so there's step 1, right? We multiplied the y values by negative 1/5. Okay, so let's get rid of the red graphs. The parent graph got dilated to become that graph. Now what? Now we're going to translate it, right? So oops. Okay. So we'll create the blue graph, right? There's the blue graph, and we're going to translate it. We're going to go left 5, because h was negative 5. So there it is. And we're going to go, was k 1? Yeah, k was 1. Okay. And we're going to go up by 1. So that's where we end up. That's our graph. Everybody agree? We dilated it, and then we kept the same shape, but we translated it. Notice that this point right here, this second point, has the same relationship that it had before we translated it. This one was over 5 and down 5. So from the vertex, that's what we do. We go over 5 and down 5 to end up at that point. Okay, make sense? Okay. All right, so no big deal. Last one. What about something like this? What if this is different now? This time, they're giving us the graph, and we're going to write the function, right? So we have to fill in the blanks. We need to be able to say what the values of A, H, and K are. H and K are pretty obvious, right? What are H and K?
Negative 5, 6.
Negative 6, 5, right?
You mean 5, negative 6, you mean?
Yeah.
Yeah.
Right, there you go, over 5 and down 6. So we can see, right away, we can see that the coordinates of that point are 5, negative 6, and so, HK equals 5, negative 6. That part's easy, right? It's A that's a little bit tougher. Right, so now we got to find out what A is. Okay, well, to find out what A is, we already know what H and K are. Let's just translate this thing back to the origin. So the vertex is at the origin, right? If we do that, what do we end up with? So here's our starting point. Right, there's our starting point. Everybody agree?
Yeah.
5, negative 6. And the other point, if we look at it, the other point that we were given is over 2 and up 1, right? Okay. So there it is, over 2 and up 1. Everybody agree? Okay? So let's scoot that thing up to the origin, right? So let's scoot the whole thing up there. If I do that, everybody agrees this is what I get. Oops, what happened there? Hang on. Okay, I want that point to be 2, not 4. 2. There we go. Everybody agree that's what I get? Okay? So I'll make the first one disappear then. We took the blue graph and we just slid it up so it's on the origin where it's convenient. Okay? So now we just need to know what value of A squishes it down like that. So let's compare that to our parent graph. Right? Our parent graph, remember, is just y equals x squared. Okay? So which is the, if I look at all those points on my parent graph, which is the point that we want to keep? 2, 4, right? Because we know that the other point that we were given was over 2 and up 1. So we want the one that lines up vertically with that has the same x coordinate, right? So we'll get rid of all the others, and we're just going to keep that one. Okay? So then you tell me now, what's the value of A? What's the value of A there?
Is that positive 4?
No, I think we start with the parent graph. Right? We multiply the parent value times A to get the dilated value.
It's 1/4, isn't it?
It's 1/4, exactly, yeah. So we're going to multiply 4, which is this value, right, times A to get 1, right? Everybody agree you multiply the parent y value by A to get the dilated y value, right? So if I solve for A, there's only one step to solve for A. What do I do? What do I do to isolate A? Yeah, I just divide both sides by 4, and I end up with A equals 1/4, right? Okay. How did we do that? We compared it to the parent graph, right? We compared those 2 points. The point that we were given to that, where that point would be on the parent graph, right? And we just ask ourselves, 4 times what is 1? Yep, 1/4. So we got that part, right? That's no big deal. Well, that's really all we needed, isn't it? We knew what H and A were. Now that we know what A is, what's my answer? We're supposed to write a function in that form, so what's it going to be? F of x equals, what are we going to put in middle?
1/4.
Yeah, A is 1/4 times x minus 5 squared.
And then minus
Plus
6.
negative 6 is just minus 6?
Yeah.
That's it, right? Okay, that's no big deal, right? Okay, last one we'll look at. How about something like...
Yeah.
Where'd it go?
I thought it just said last one.
Yeah, right. Oh, I know what to do. I'm gonna do that. That one right there.
Down there already. Origin. You know how we got there?
Okay, what about this guy?
How do you do that? You know?
You have to change it from that to square form, right?
Okay, so I've got to write the function first. So let's, first of all, we got to figure out what the values of A and H and K are, right?
That's what it is.
Okay, so what are H and K?
6.
Good. So over 6, up 0. Now what about A? A's, you got to be careful with A, right? So think about this compared to the parent graph. If I put this thing so it's centered right on the origin, right? So let's scoot it over so this becomes, oops. So that becomes the y-axis, and that becomes the x-axis. So now we're saying the coordinates at that point right there are 0, 0. What are the coordinates of that other point?
1/5.
1/4.
Oh, whoops.
Okay, so we got to compare that to the parent graph. Where would the parent graph be? If I go over by 1, if I have the same x value, where's the point going to be on the parent graph?
1, right?
1, 1, right? Good, I go over 1 and up 1. Okay, so then we're going to multiply the parent y value right? That's all we do. The parent y value times a equals the dilated y value, right? So that's a simple equation. All we're saying then is 1 times a equals 4, right? So what's a?
4.
4, right? Makes sense. We stretched it up by a factor of 4, didn't we? Okay? So if a is 4, we know h and k are 6 and 0, then what do? Right? From there, all we have to do is plug that stuff into vertex form first, right? So we'd start off with a, which is 4, times x minus 6 squared plus 0, right? That's my answer, but I'm supposed to put it into standard form. So what do? I just simplify it. Just follow order of operations, right? So if I follow order of operations, right? What's that going to give me then? So if I follow order of operations, inside the parentheses, there's nothing to do. Exponents, yeah. Look at that. I've got an x minus 6 squared, right? So I have to square that out. Yeah, I don't know why. I got to fix that. That shouldn't be in there. Right, so then I'm just going to, this is literally taken from the solutions, right? I'm just going to take x minus 6 squared, and what's that going to give me? If I multiply that out, go ahead. If you don't remember the pattern, I don't care. Just multiply it out. X minus 6 squared is just x minus 6 times x minus 6. If I distribute the x, what do I get? X times x is?
X squared,
X times negative 6 is?
negative 6x.
Okay, now if I distribute the negative 6 times x, and then negative 6 times negative 6.
Plus 36.
Okay, so if I just add up the like terms, I've got some like terms right there. X squared minus 12x plus 36, right? So then all I'm going to do now, so that's step 1. That was the exponent part. So I'm going to replace what used to be an x minus 6 squared, right? So everything in the box is going to get replaced with all that stuff, right? What's next? So I did exponents, now I multiply. Well, multiplying means distributing, right? I'm going to distribute the 4. So if I multiply the 4 all the way through, don't I just get 4 times x squared minus 48x plus 144, right? Last step is add, and if this time I don't have anything to add, right? Because my other number was a 0. Where is that? Right there. I'm adding a 0, but what if that had been what if it had been like a 5 or something? Then I would have just combined I would have added the 5 to the 144, and that would have been my final answer.
Really?
Okay, that's no big deal, right? You guys can do that. Okay? All right, you have a little time. Why don't you grab a Chromebook quickly and get going?
Oh, yeah, sorry, one question on that.
Yeah.
It was the previous question to this. We started off